Alright, so let's use the concept that we learned in the previous video to solve. If a 1.5 current flows through an aqueous solution of copper 2 sulfate for 25 minutes, the amount of charge passing through the solution is, so we use the formula. So, ang given nato diri is the current, which is 1.5 amperes, and we're given the time nga 25 minutes. And then, we're looking for the charge Q. So the formula for finding the charge is I times T, that's the current times the time, and this is 1.5 amperes times 25 minutes. But we have to remember that the time must be in seconds, so we have to convert, and we know that there are 60 seconds for every 1 minute. And using the calculator, we'll be able to get that the charge here passing through the solution is 2,250 coulombs. Next, we find the number of moles passing through the solution. The number of moles of electrons passing through the solution. So, N, for the given amount of charge, for the given charge, pila man ka number of moles of electrons passing through the solution. So, N here is equal to, so, unsaon man nga mole electron ang mahabilin. So, gikan ka og 2,250 nga column. So, you can just use dimensional analysis. We know nga there's 96,480 coulombs for every 1 mole of electron. And so the number of moles of electrons transferred here is approximately 0.0233 mole electrons. But in the reduction of copper 2 ion, we need to write the formula here. So that's copper 2 plus in the solution, aqueous solution, and to produce copper nga solid, then 2 mole electrons must be transferred in the half reaction. Pero diri, kung kani kuno ang charge ni flow, then kani nga amount of mole electrons ang transferred. Okay. The amount of copper formed at the cathode therefore is, so gikan sa N, we will solve for the mass. So the mass is equal to, so pila tong N na to, it's 0.0233 mole electrons transferred. So kaning mole electrons, ato ni siyang i-convert to mole. So from mole electron, himuon nato siyang mole, and then gikan sa mole, himuon natong grams. Okay? So, unsa may conversion factor nato from mole electrons to mole? So, kani ato ang half reaction. No? Nga we know that for every 1 mole of copper plated, 2 mole electrons are transferred. Alright? So, 1 mole of copper requires 2 mole electrons transferred. And unsay conversion factor nato para sa mole to gram? So, ihang atomic mass. So, for copper, the atomic mass is 63.55 grams for every 1 mole. And then you just use your calculator to multiply, and it will give us approximately 0.741 grams of copper nga na plate given the current and the time. And if you are not able to get this, so please do not use 0.0233 but instead use the exact value, dili ning rounded off nga value. So if the process uses a cell voltage of 3 volts, pila may energy nga makonsume sa process? So the formula for energy, E, is equal to the charge times the voltage. So ang charge nato nga gigamit is 2,250 coulombs and the voltage is 3 volts. So the answer is 6,750. The unit here is joules. So kahibaw ka sa charge, makahibaw ka kung pilay energy nga needed for the reaction to happen. Okay? So let's solve this example. Chromium metal can be electroplated from an aqueous solution of potassium dichromate. The reduction half reaction is given. So we are already given here the reduction half reaction. A current of 6 amperes and a voltage of 4.5 volts are used in electroplating. How many grams of chromium can be plated if the current is run for 48 minutes? So ang atong gipangita diri kay basically the same thing as what we did in the previous nga kuan. So gikan sa I and time, we solve for Q, and then from Q we solve for the number of moles of electrons, and then from that we solve for the mass, and then we already have the answer. So instead of doing it step by step, you can just actually write it directly. So pwede ta mo solve lang sa Q. So solve Q. So Q equals the current times the time. So current is 6 amperes and the time is 48 minutes. And then we have to convert, so 60 seconds for every 1 minute. So we see here that Q is equal to 17,280 coulombs. Okay, and then what's next? Pwede na actually diretsohon na to og mass. But let's do it step by step, after which we solve for N. So N is equal to the number of moles of electrons is equal to so gikan ta sa 17,280 coulombs, we use Faraday's law. 1 mole of electron for every 96480 coulombs, and that will give us an answer of approximately 0.179 mole electrons. And then after which we solve for M. So 0.179 mole electrons, and then from here we can see that for every 2 moles of chromium, 12 mole electrons are transferred. So magbase gid ta diri sa ato ang half reaction. So 2 mole Cr na ay 12 mole electrons. So this is just actually dimensional analysis. And then we know atomic mass for every 1 mole of chromium, that's equivalent to 52 grams of chromium. And so, makancel ni siya, and then we will be able to get approximately 1.55 grams of chromium. Okay. Next example. How long, so this time we're looking for the time, how long will it take to deposit 20 grams of aluminum from an electrolytic cell containing aluminum oxide at a current of 125 amperes? So let's try to write the reaction here. So aluminum man deposited. So ang sa aluminum oxide, so that's Al3+, that's an AQ, that needs 3 electrons to produce aluminum nga solid. So we're given the current and the mass. So we're looking for the time. So if we look for the time, we need to find, kinatay A, not A, but we need I. So the current is given, which is 125 amperes, but we do not have Q. So kinahanglan pa ni siya isolve before we can solve for T. Okay? So how do we solve for Q? So gikan sa mass, from the mass, kinahanglan ta maabot ni Q. So baliktad na. So from M to N to Q. Baliktad ang process sa ato ang gi-solve compared sa previous nga 2 examples. So, pwede ra na siya diretsuhon class, dimensional analysis Q. Asa man ta magsugod sa mass. So pilay mass sa aluminum? It's 20 grams. So si grams atong i-convert to moles. And aluminum has atomic mass of 27 grams. So 27 grams of aluminum for every 1 mole of aluminum. And we can see, so na moles na siya. Muna na siya ang N. Gikan sa mass na N na siya. Mole. And then we have to convert mole of electrons pa di ay. And as we can see from the half reaction, we can see that for every 1 mole of aluminum plated, kinahanglan siya og 3 mole of electrons transferred. So nanatay N. Cancel. And then, gikan sa number of moles of electrons, padung na ta sa Q. So, Faraday's law na dayon nga 96480 coulombs for every 1 mole of electron. And using your calculator, you will be able to solve for Q, and that would give us an answer of 214,400 coulombs. So now that we have Q, we can now solve for T. So, diba? Q is equal to I times T. So, T therefore is equal to Q over I. So, we just divide 214,400 coulombs. Remember that if you rounded it off, please use the exact value and then divided by I, which is 125 amperes. So, how long will it take? So, wala man siya niingon og units sa time. So, we will use the unit seconds. So, that's 1,715.20 seconds. So, that's how the time it would take to deposit 20 grams of aluminum using the current nga 125 amperes. Next, how many grams of silver will be produced if a current of 1.5 amperes passes through a solution of silver nitrate for 30 minutes? So again, we write first so Ag plus electron, so silver nga solid, Aq here, and then so mass, so parihara ni sa example number 1. So 30 minutes and time. So we start from Q and then to N and then to M, no? So first, let's solve for Q. Solve Q. So Q is equal to I times time. So 1.5 amperes times 30 minutes, and then that's 60 seconds for every 1 minute. And Q here, solving, it's 2,700 coulombs. After which, we can now solve for M. So the mass plated, so you can start with coulombs, so 2,700 coulombs para diretso na lang, and then 1 mole electron for every 96480 coulombs, and then after which, so that's already the number of moles of electrons, and from the half reaction we can see that 1 mole of silver is plated for every 1 mole of electron transferred, and from mole to mass, 1 mole of silver is equivalent to 107.87 grams of silver. And computing, we get 3.05 grams of silver.